Imagine holding the universe in your hand, all its stars and planets. Feel the weight of countless worlds, the vastness of space condensed into a single tangible object. It's a humbling experience, isn't it? To think that all of this, the entire cosmos, could be within your grasp. Now imagine shifting everything just a bit, placing the sun at the center. This simple yet profound change alters our entire perspective. The universe, once thought to revolve around us, now dances around a different focal point. That's what Nicolaus Copernicus did. He didn't physically move the universe, of course, but through his revolutionary ideas, he moved the minds of countless individuals. He shifted the paradigm, challenging the very foundation of our understanding, but he changed how we see it, how we understand our place within it. The night sky, once a mystery, began to reveal its secrets. Stars and planets, once thought to be mere decorations, became subjects of intense study and fascination. Copernicus dared to challenge centuries of established thought. He questioned the geocentric model that had dominated for so long. His courage to think differently paved the way for future astronomers and scientists. He placed the sun, not the Earth, at the center of our solar system. This heliocentric model was radical, yet it explained the movements of celestial bodies more accurately than ever before. His ideas sparked a revolution of thought, of understanding, and of exploration. Scholars and scientists began to see the universe in a new light, questioning old beliefs and seeking new truths. This revolution wasn't fought with armies, it was a battle of minds, a clash of ideas. In the quiet corners of libraries and observatories, the seeds of modern astronomy were sown. It was fought with ideas, with observations, and with a new way of looking at the cosmos. Through meticulous study and relentless curiosity, humanity began to unlock the mysteries of the universe, forever changing our place within it. Nicolaus Copernicus was born in 1473 in Torun, Poland. He lived in a time when most people believed the Earth was the center of the universe. This was the accepted truth, taught for generations. Young Nicholas, however, was curious. He questioned the world around him. He studied mathematics, astronomy, and philosophy. His education took him to some of the finest universities in Europe. Copernicus soaked up knowledge like a sponge. He learned about the movements of the planets. He studied the ancient Greek astronomers. His mind, always questioning, began to see problems with the old model of the universe. For centuries, the prevailing view was geocentric. This meant Earth was considered the center of the universe. The sun, moon, planets, and stars, everything revolved around us. This model was supported by the great thinkers of the past. Ptolemy, the ancient Greek astronomer, had developed a complex system to explain the movement of the celestial bodies around a stationary Earth. His model, though inaccurate, worked well enough to predict planetary positions. It became ingrained in the scientific and religious thought of the time. Copernicus, through his meticulous observations and precise calculations, began to doubt the long-standing geocentric model which placed Earth at the center of the universe. This model, endorsed by the Church and widely accepted for centuries, seemed increasingly flawed to him. He found that the complex and often contradictory movements of the planets made far more sense if the sun were at the center of the universe. This heliocentric model, with the sun at the center and the planets, including Earth, orbiting around it, provided a more coherent explanation of the observed celestial phenomena. This was a radical idea, one that flew in the face of established doctrine and centuries of astronomical tradition. It was not just a scientific proposition but a revolutionary shift in thinking. It challenged the very foundation of astronomical knowledge and the prevailing worldview. The geocentric model was deeply ingrained in the scientific and religious fabric of the time. Copernicus proposed a heliocentric model, the sun at the center, with Earth and the other planets orbiting it. This model not only simplified the understanding of planetary movements but also provided a more accurate framework for predicting celestial events. This elegantly explained why some planets seemed to move backward in the sky, a phenomenon known as retrograde motion. In the geocentric model, this required complex and convoluted explanations, but the heliocentric model made it straightforward. It simplified the complex system needed to explain planetary movements in the geocentric model. The heliocentric model reduced the need for epicycles and other cumbersome mechanisms that had been used to account for the observed motions of the planets. Copernicus's idea was a simpler, more elegant solution. It was a bold step towards a more accurate understanding of our place in the cosmos. laying the groundwork for future astronomers like Kepler and Galileo. It was a glimpse of the true nature of our solar system, a revolutionary idea that would eventually transform our understanding of the universe and our place within it. Copernicus's heliocentric model was not just a scientific breakthrough, it was a profound shift in human thought. Section 5. A universe of resistance, doubts, and delays. Copernicus knew his ideas were controversial. He hesitated to publish his work. He feared the backlash from the church, which held the geocentric view as dogma. He also worried about the scientific community, steeped in tradition. He shared his ideas cautiously, mostly through letters and manuscripts circulated among trusted colleagues. For years, his groundbreaking work remained largely hidden from the public eye. The fear of ridicule and rejection kept him from shouting his truth from the rooftops, but the revolution was already brewing. Section 6 De Revolutionibus, the book that changed the heavens. In 1543, close to his death, Copernicus finally published his masterpiece. This was a time when the world was still deeply entrenched in the geocentric model, which placed Earth at the center of the universe. The courage it took to challenge such a deeply held belief cannot be overstated. It was titled De Revolutionibus Orbium Coelestium, on the revolutions of the heavenly spheres. This title alone hinted at the groundbreaking ideas contained within its pages. This book laid out his heliocentric theory in detail. Copernicus proposed that the Sun, not the Earth, was at the center of the universe, and that the Earth and other planets revolved around it. This was a radical departure from the Ptolemaic system that had dominated for centuries. It presented mathematical calculations and observations that supported his claims. These calculations were meticulous and detailed, providing a robust framework for his revolutionary ideas. Copernicus used complex mathematical models to explain the apparent retrograde motion of planets, which had long puzzled astronomers. Copernicus dedicated the book to Pope Paul III, perhaps hoping to soften the blow of his revolutionary ideas. By doing so, he sought the Church's acceptance and protection, knowing well the potential backlash his work could provoke. The book's publication marked a turning point in the history of science. It was the spark that ignited the scientific revolution, inspiring future astronomers like Galileo and Kepler to further explore and expand upon his ideas. It challenged the very foundation of how humanity viewed the universe and our place within it. The heliocentric model not only redefined our cosmic perspective but also laid the groundwork for modern astronomy. It was a bold assertion that the universe was far more vast and complex than previously imagined, forever altering our understanding of the cosmos. Section 7. The Legacy of Copernicus, inspiring generations of thinkers. Copernicus did not live to see the full impact of his work. He died shortly after the publication of De Revolutionibus. His ideas, however, continued to spread. They sparked debate and controversy. They also ignited the imaginations of scientists across Europe. Copernicus had planted a seed. This seed would grow into a scientific revolution. It would change our understanding of the universe forever. Section 8. Galileo's telescope and Kepler's laws, building on a foundation. Copernicus's work laid the groundwork for future scientific breakthroughs. Galileo Galilei, armed with his newly invented telescope, provided observational evidence that supported the heliocentric model. He observed the phases of Venus, which could only be explained if Venus orbited the Sun. Johannes Kepler, building on Copernicus's work, developed his laws of planetary motion. These laws accurately described the elliptical orbits of planets around the Sun, further solidifying the Copernican model. Copernicus's legacy was not just in his theory, but in the scientific inquiry he inspired. Section 9. Shifting Paradigms, the Copernican Revolution and beyond. The shift from an Earth-centered to a Sun-centered solar system is known as the Copernican Revolution. This revolution was more than just a change in astronomical models. It represented a fundamental shift in how humanity saw itself in the cosmos. No longer the center of all creation, Earth became just another planet orbiting the Sun. The Copernican Revolution was a crucial step towards a more scientific and less anthropocentric view of the universe. It paved the way for modern astronomy and our current understanding of the vastness of space. Section 10. Dare to Challenge, Copernicus's enduring lesson. Copernicus's story is a testament to the power of curiosity and the importance of challenging established beliefs. He dared to question what was considered an absolute truth. In doing so, he opened up new ways of seeing the universe and our place in it. His courage to challenge the status quo is a lesson for us all. We should never be afraid to question, to explore, to seek new knowledge and understanding. Section 11. An invitation to explore, unveiling more hidden figures. The history of science is filled with stories of individuals who dared to think differently. Take some time to learn about other great thinkers who challenged the status quo. Explore the lives of Galileo, Kepler, and Newton. Discover the contributions of lesser-known figures like Hypatia of Alexandria and Johannes Müller. The more we learn about these pioneers of science, the more we learn about the power of human curiosity and the boundless potential